So if you choose your domain well, you'll choose a database well, your database will have 90% of what your API models should also have. All you need is a layer that does the web protocol transformation and that does the authorization and security for you that database will not do. That's the only thing you want to do with this layer.
This is DevOps Paradox, episode number 231, Automating API Development with Hasura. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, we keep on talking about being old. I guess it's more me than you at this point.
We're close. We're old.
We're close. Well, let's think about it this way. Do you remember the time before you could actually generate code to generate code?
Before I could generate code to generate code, I don't know. This is too philosophical for me, man.
Do you remember handwriting all your code in the past versus maybe doing a little bootstrap and say, go do this and it generates everything for you? Do you remember the time before that? Before scaffolding, I guess is the word I'm looking for.
That reminds me of the time when I was actually buying magazines with the code and then I was handwriting them, yes.
You do remember that. That's good. On your, what were you using? You weren't Sinclair, you were...
I was Commodore 64.
Oh, okay. I thought you had some weird Z-named computer back in those days.
I had Amstrad.
The Amstrad. That's what I was trying to remember.
Yes.
Okay. Why are we talking about writing software out of magazines? For you children, maybe not so much children, maybe if you're under 40, you don't remember those days. Those were wonderful days. This was before, really dating myself, this was before AOL had discs in magazines. Again, old people problems today. Today we have Tanmai on from Hasura. Tanmai, how you doing?
Hey, everybody.
So with Hasura, one of the things that they do is never having to handwrite API stuff again. Now, we all love handwriting APIs. In fact, if we go back to the time, no, we all hated that. I remember the initial days of Swagger, and I thought, holy cow, I can generate code from a Swagger definition.
Hey, initial days of Swagger were so awesome that nobody wanted to use it in practice because nobody wanted to write those definitions, the schemas.
Okay, I didn't want to say that out loud, but
it sounded so cool, and then the next week, no.
Do you remember those days, Tanmai?
I've come across kind of folks doing that and then getting a little bit frustrated, exactly like, what you folks are talking about. It's been interesting. That's definitely prior art that we looked at and ensured that that's not a trap we fall into again. But it's hard to avoid, right? Because you kind of need to auto-generate from something. The question is what that is.
So we're using that history to sort of set up, okay, what are people doing today? And let's try to leave Hasura off the roadmap as much as we can right now. If we weren't writing code by hand and we weren't going to be using something like Hasura or even, let's go and say it's Swagger or OpenAPI today, what would we be doing? I mean, what would that world even look like?
Yeah, I think in the space that we're in, we see this happening most of the times where people are writing code by hand for their APIs, right? And it's fairly repetitive stuff. So what you're doing is the kind of APIs that I'm most exposed to is web APIs, right? So what people are doing when they're writing web APIs is you're using frameworks like maybe Django or Rails, you're using PHP, .NET, maybe TypeScript, Go, right? So you're using kind of frameworks and programming languages, and you're using that to kind of build these functions that contain some code, some logic, some kind of data fetching, right? Some kind of authorization stuff. So you're writing that code in a function, and then you're using some kind of framework or system to expose that function as a web API, right? So this controller becomes a API that you expose that is HTTP. It's going to take stuff over a JSON protocol. And that's what people are kind of doing today, or what people would do if they weren't thinking about more meta ways to kind of bootstrap this process of writing code.
I haven't been working directly with APIs for a long while. I'm very focused on, I'm still working with APIs, but very focused in Kubernetes, where nobody probably even thinks about writing anything before writing a schema, and then everything falls from there. Is it very similar?
Yeah, exactly, right. I think like the idea that the kind of prior art that I really think about here is databases. So if you think about databases, right, you think about it's a system that gives you an API to access data on some storage layer, right? Something like a disk or files or CSV or S3, whatever it is, right? That's what a database is. And you don't write code to get data access APIs. You don't actually write code to get API to access data. What you do is you do DDL. You define a model, a table, and then what the system does for you is gives you a SQL API. And the SQL API is so powerful that you can do a whole bunch of things that you wanted to do with that data. So you're kind of auto-generating the API. You're giving it the model and you're getting an API. And the reason why SQL is so popular and kind of feels like it's never going to go away is because it composes so well, right? It's the idea of like, well, here's one model, here's another model, another table. And now the API kind of just composes across both. So every model or every table that you add in the definition of your system, you get this compounding effect of this auto-generated API. It's just that SQL is so nice as an auto-generated API that you think of it more as a language. It is an API, but it's so nice and composable that it's a language. So that's kind of really the prior art that I think about when we think about this idea of auto-generating APIs. Does that make sense?
I never thought about it that way, but you're right? SQL is an API in a way. And we always start by generating schema, which is essentially API schema, right?
Exactly.
And that sounds very different from my prior experience with writing code, right? You would fire up Java, JavaScript, Go, whatever you are and doing, and then you would write code that would end up being that schema.
Yep, exactly.
It's kind of the other way around.
Exactly.
It doesn't make sense.
And that's why it kind of is fascinating to see how much of a speed up one can potentially get by thinking about this approach, right? If you think about this approach of saying, what is my web API? It's essentially some kind of logic that allows me to access data in an underlying database. It's applying certain transformations on it to make sure that it's kind of a web API, right? It's like a JSON HTTP. That's the code that you write, right? You're writing an API to fetch, let's say, from example, you're in the Kubernetes world, right? Let's say you're building that Kubernetes API, right? What is it? It's essentially an API on etcd. That's what it is, right? That's what kubectl gives you on the read side. So what you're doing is you have kind of this logic that is transforming JSON into something that the underlying data system speaks. It does this element of the transport layer is different. It's HTTP, and the transport layer there is probably TCP, right? But behind the API. Most importantly, the kind of business logic that is not, let's say, for example, the logical model, right? The domain model, that conversion of the physical model that you have at the data layer, converting that into the domain model, which is the business model that you have, that a user has ID and first name and last name and age. There's kind of that transformation that happens. That's a critical piece of the API layer. The most other important critical piece that I think is perhaps 90% of the code that you end up writing by hand is actually what I call authorization and security business logic. It's basically business logic that you're putting in place to ensure that only the right people can access the right kind of data. If you're a user, you can access your own data. If you're a user, you can access your family members' data, your family members' accounts, you can transact on it. That's kind of authorization that you have. And the same kind of authorization on the read side is access control, but on the write side is validation, right? So you're doing input validation. So you're checking if somebody's giving you data before you actually insert it into the data models that you have, you're checking if it's valid or not. That's essentially what your API is, right? It's this logical model and its authorization logic. That's probably most of the code that you're writing when you're building a web API. Does that sound right to you?
And I'm asking mostly because I'm not into it, so I don't know the details anymore, right? Excluding the authorization layer, the validation layer, that's part of that schema, whatever the schema is, right?
Correct.
When you're defining, I'm going to have a first name, last name, you're defining, okay, both of them are strings, it cannot be more than 30 characters,
Yep.
etc., 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 right?
Exactly. And so if we, again, kind of think about what the web API does, which is, like you said, the schema contains validation. And I would say that you also need to add those authorization rules and access control to it, right? So that's what your API is supposed to do. And if you take a step back and you think about how databases solve this problem, and I'm sure you folks are familiar with Oracle and Postgres and the original, when relational databases first started out, they had something called row-level security. RLS and row-level security was this very advanced authorization engine that databases had, and some of them still have, that allow you to do really fine-grained authorization that does exactly what we talked about. It does validation and it does access control. So you can do some really specific stuff, right? You can say, I have access to this bank account if like I'm a logged in user that has like this property and I'm 18 years old and I'm in this family member of the family account and all sorts of really complex stuff that is a property of the data and it's a property of the user trying to access the data. Fine-grained controls that give you access to the right row and the right columns inside a database. Same thing on the validation side. You can set up really fine-grained constraints on the data models that you have before you kind of operate on that data model, right? Like you said, first name should be less than 30 characters and only ASCII and UTF-8 is allowed, right? And you can kind of actually add that in your authorization rules or in your schema, one of those two places. And then the database gives you an API that is secure and authorized and it works. But what happened, and the way that we think about it, is this idea of having this critical business logic inside the database did not scale. Because people started to build like web applications and web APIs, and trying to expose your database to web scale workloads was not feasible. Nobody wanted to do that. It's too scary, right? Like a bank exposing its database and saying, yep, everybody go, like just have your Android apps connect directly to my central mainframe. And that's okay. Just doesn't work, right?
That sounds very similar to the idea that we had a long time ago to create something called XSL to actually add the logic we normally keep in code inside of XML, right? Is that a similar parallel, right?
Right. That's another prior art and another analog. The same pattern has happened before, right? Where you've seen this kind of pattern where it's like you try to shift that logic and make it declarative and put it in XML instead so that it's not coupled to the database. But for a lot of like startups and like web kind of companies that came out and web digital modernization kind of stuff that started happening when people were building the next generation of their products in enterprise, is they said that we can't keep this code that is so close to the database. We need it to be at a layer outside the database in our API so that if the time comes and we need to scale out our database, we need to change our database, we need to use multiple databases, all of that is possible. Kind of one of the ways that I think about this entire evolution, and this might be a little bit controversial, is that I think it's because a lot of database companies were so predatory in their practice early in the 90s, early 2000s, right? They got really predatory. They said like, we're going to charge you for every line of business logic or authorization code you put inside the database. And people got really angry and they were like, nope, I'm going to put my logic outside the database so that I'm not like tied to this massive license fee.
That's also the time when we, and correct me if I'm wrong, right? When we thought that it's a good idea to have one massive database and then many applications interacting with those single database. And then the only place where you can put certain rules is the database itself, right? While we are now moving more towards, okay, there is a service or application that owns this database. Nobody else can talk to the database. They talk to me, and I talk to the database, right?
Exactly. That's why we needed to do this, where we needed to kind of say that let's stop doing this direct access business and build a service instead.
Exactly. So kind of the rules, it's not that the needs changed in a way once we switched from one megalithic database.
Exactly, right? But interestingly, this is the kind of gap that we spotted, right? Was that the same idea of having a declarative schema and having declarative authorization rules, that same idea is still valid. It's not valid to put that inside the database because you want a service layer, you want a web service layer so that you can decouple and you can switch out and you can scale out and you can migrate and evolve, right? You can handle more kind of complex authorization tenancy logic. So that idea is still valid, especially if you're building data APIs, right? You're building a service that is going to encapsulate the database and that is going to talk to so many different types of teams that you have inside the company, so many different applications. Maybe it's going to talk to a web service, maybe it's going to talk to a mobile application, whatever it is, right? The idea of saying that maybe we don't have to write the API, but maybe if we can provide a declarative authoring engine to say, if you can describe the schema of what is there in one or more databases, the logical models, the domain models, and you can specify your authorization rules, and we'll give you an API, a composable GraphQL API directly.
Give you the service that will represent that API, right? Sitting in between you and the database.
Exactly, sitting between the application and the database so that you don't have to build this microservice by hand. This service is so much faster to build. Instead of spending, 1 week to build a production grade API and doing caching and documenting the API and making sure you have pagination and filtering and sorting and like you can do user and user dot accounts, right? You can like join stuff and do query planning and it's a lot of work. It's a lot of repetitive, unnecessary work. The core of it is the idea of a logical model and the idea of authorization. And so if we can allow people to declaratively specify that, we can actually start to auto-generate this API experience. Just like SQL for the database, when we're coming to the web world, we do GraphQL. And GraphQL is a phenomenal composable API for JSON. It allows you to compose stuff from multiple databases. So you can say, I want user and user.accounts, and actually user is coming from the database, from one database, and accounts is coming from the second database, right? It's coming from a streaming system, there's events, and the events are in Kafka and they're converted to a JSON payload. Doesn't matter, right? It doesn't matter what that data layer is. The nice thing is that you have this amazing web API, enforces security and authorization, and captures and encapsulates your business domain. And so that's kind of the crux of the idea that we kind of started with.
So GraphQL in that context becomes unification in a way, right? I have this entry point and I will go to one database or 7 databases or queues or whatever, and I'm going to get it back to you. GraphQL in this context is basically the same as what we had with DBSs a while ago in a way, conceptually.
Yeah, conceptually, yeah, you're right. It's fulfilling the same kind of business problem in a way, right? It's just that the developer experience is like 10 times better. When we think about like, why is this business of having data APIs becoming so top of mind today, right? And the reason why that's happening is exactly what you were saying, a few minutes earlier. We don't have a megalithic giant database that does everything. It's not even possible anymore. But you have a lot of databases. And the very interesting thing that's been happening in the ecosystem, I was just looking at the statistics, it seems that in the last 4 or 5 years, there have been more than 1,000 database and database adjacent startups that have been funded and databases that have been created. And I'm not even talking about like open source databases, like hobby things that people are writing and that are kind of gaining popularity, but these are actually funded companies in the database space, which is insane because that's the demand that people have to say, I want a database that's specific for this kind of workload, that's specific for this kind of domain, that has this kind of consistency property or availability property or scaling property, right? Today, if you choose a niche workload, there is a database that is actually out there that can almost give you infinite scale if you choose the workload. So you make a specific workload, you're going to get a database that works for you and you don't have to manage it, and the experience is amazing. Like, it's not a better time to build cool applications. There never was a better time compared to what we have today, right? Just the ability to say, man, I have this time series data that I need like instant real-time analytics on. You've got like 3 or 4 options that are rock solid, world-class, will scale to like petabytes of storage. You say you want something on NoSQL or queues, it's an amazing time.
Am I wrong in saying that databases were maybe the last segment of the industry to realize that? While we were all switching from the idea, okay, so maybe Java is not the best thing for both front end and back end. Maybe we should use something else for this, and so on and so forth. And databases were somehow sticking to one database to have any type of data longer than anything else.
Yes, that's true, right? That is so true. And it's in a way, if you think about it, it's hurt the ecosystem, right? It's like it's prevented our ability to innovate. Only now it started to happen, exactly like you said. It's just happening right now where people are like, the future is polyglot data. It has to be. If I want like fast real-time analytics on massive data, ClickHouse is a great choice, but it's not going to do amazing OLTP workloads for me. It's not going to be a streaming system for me, right? It's not going to give me like amazing, like flexible data types like Postgres. It doesn't need to. Databases have kind of finally caught on to that idea that it's okay to specialize on a particular workload because everybody has lots of different workloads and it's only increasing the amount of data that we have. So let's specialize and let's provide best-in-class, best-of-breed solutions for that vertical, that very specific kind of workload.
You mean we finally realized that it's okay to be very good at something instead of being bad at everything?
Yeah, I mean, it's a tangential conversation, but it's like, I feel like the reason why that's happening is because data has so much gravity, right? That anybody who's a database vendor doesn't actually want to innovate. They want to keep all the data inside that same database. You don't want to have people go outside your database ecosystem. So you actively resist any innovation that tries to do that.
To be fair, also, data is the last thing that companies want to play with also.
Exactly.
Kind of, I'm more willing to experiment with Go for something than play with my data. Because if I lose code, that's better than data, right?
Yep. That's exactly it, right? But if you look at the tension that it's creating, right? You have so many databases, you have so much new data being generated, but we just discussed that it's not a good idea to expose these databases directly to multiple applications or to build products directly on this data. So that means that you need to go ahead and build lots of microservices. So that means that every time you evolve the way that you're thinking about data, or you generate new data, or you migrate data, right? You have to staff up and build microservices. And that means that you have to build a service, you have to build an API, you have to document the API, you have to publish the API, you have to do SRE work on the API. It's a lot of work. And that's kind of where you need APIs and you hate building APIs, right? And that tension is becoming even more apparent like every single day where we're generating more and more data.
To be honest, I always thought that those types of services are the dumbest thing anybody can do. No, literally, look at it. So my experience, and it's based in the past. I haven't been working on that area for a while, so I don't know how much it changed, but it was, okay, we defined database schema. Cool, right? And then we define an API of a service that will sit in front of the schema that is going to be exactly the same as the schema.
Yes.
Exactly the same.
Yes.
The only difference is that I don't have varchar.
Yes.
I have string.
And it's string instead.
Exactly,
Yes.
it's string.
Yes.
But it's going to be exactly the same. But it doesn't stop there. Then I'm going to create a library so that other applications are going to import so that they can talk to my API, and that library is also going to be the same.
Yep.
So I'm doing monkey business over there.
Yes. That's exactly the situation, right? That is exactly the situation. That's exactly kind of where we were sitting and we were like, man, we've really got to speed up the process of like innovating and building cool product. But if we want to build cool product and cool experiences and cool like business logic that is like adding value to the business for the end users, right? And that was happening over the last few years. But even now, when you think about AI applications that people want to build, where they want to like get all of the data and then automate that and do stuff, you need access to data to do cool stuff. But to access data, you have to do this monkey business of like, I've already done data modeling in the database. Now you want me to do data modeling again in Go and then do data modeling again in something that I consume. You're like, what is going on, right? So you don't want to do this repetitive like work, but you do need an API. You still can't say, man, can I just get rid of the API and access the database directly? You can't do that. But you do need to build an API. And the API is largely 90% of it is what you already have in a good database, right? Look, if your database is like a CSV file, then you don't have a schema, right?
Then
you need to do a
Then you
right,
go,
exactly.
go somewhere else.
yeah, exactly, right? But if you're using a good, high quality modern database, right? The reason why it's a database is because it's probably doing 90% of your domain modeling anyway. You're choosing a time series database for a time series domain model. You're not trying to create a time series domain model on a Postgres database because that's not going to scale beyond a point, right? You're going to go do that in a database that can handle time series, right? So if you choose your domain well, you'll choose a database well, your database will have 90% of what your API models should also have. All you need is a layer that does the web protocol transformation and that does the authorization and security for you that database will not do. That's the only thing you want to do with this layer. So if I can make that process 30 seconds or 1 minute or 2 minutes, instead of making that like a 3-month or 6-quarter waterfall agile that is actually waterfall, right? Like instead of doing that, if I can just get this, then I can go and start building cool stuff, which is what I wanted to do in the first place. That's the idea.
This episode has turned into buzzword bingo.
Wait, we didn't...
In a good way. In a good way.
We didn't even talk about AI. What do you mean buzzword?
No, he did. He did.
He did?
No, he did.
Okay.
Well,
then let me
I
throw
drop
the
it in.
Chat GPT kind of just
Okay, there you
to
go.
have another word.
That finishes it up.
LLM.
Yes.
There you go.
So we've been talking about GraphQL. And I'll be honest, I have not done the history on GraphQL. I'm used to REST. Why would I pick GraphQL over REST? Because it's just data in the end, right? I can send back a JSON REST blob as easily as I can send it back a GraphQL JSON blob.
That's a great question. So 2 key challenges with REST that GraphQL seeks to address. The first challenge is that it turns out that in most cases, when people are consuming REST APIs, they won't stop at consuming just one REST API. What they'll often want to do is they'll consume multiple endpoints to fulfill a particular data request. So you'll want users, and then you'll want their accounts. And then for each accounts, maybe you want like the top 5 recent transaction. You need a bunch of data to do something useful. And that something useful could be rendering it on a screen that shows you your account page. That something useful could be doing some business logic in some other service, right? That generates a report, maybe internally, right? For doing things, you'll need to access data that requires multiple API calls, right?
So here's a challenge, playing devil's advocate. And I'm going to exclude the case where you consume third-party APIs, right? Why not create a service that will expose all those things to me as REST API?
Exactly. It takes away the burden of creating those REST APIs. But what it does not take away the burden of is somebody who's integrating with these APIs. They are fetching a lot of unnecessary data and making a lot of unnecessary network calls. So this experience of fetching that data, right? If you think about like the N+1 problem, like it's literally like I have to have a for loop. I fetch user, and then for each user in user, make this API call. And then for each account in accounts, like the list, make an API call. It's not a great integration experience when you're thinking about, even though the APIs already exist. Similar to this problem is because the REST API sometimes, like if, especially in enterprise kind of environments, right? The user will have 100 attributes. You didn't want the 100 attributes. You just wanted ID, first name, and last name. You didn't want those 100 things, right? So you're getting so much unnecessary data. You're getting so much in your memory that is unnecessary. You're processing all of that. Sometimes this doesn't matter, but in a lot of times it does matter, which is when you're kind of building applications that are on the edge, that are more like on serverless functions, that are more like with the web mobile kind of networks, right? Where that network cost, the difference in latency in sending 2 kilobytes and sending like 50 kilobytes is significant. And that only adds up, right? If you have like very concurrent usage, you have data egress charges, it's actual cost that somebody is paying, especially at scale. So that's kind of one problem on the integration side, even if you assume that the APIs already existed. So the only way to solve this problem is to build custom REST APIs for every single use case, right? So I'll be like, hey, Victor, tell me exactly what you need. Just tell me exactly what data you need, and I'll build a custom API for you to give you exactly that data. And if we do that, we're stuck. You're waiting like 3 weeks for me to give you that API endpoint. You're caught in this rock and a hard place situation of like, it's too slow to get the perfect API. And it's kind of like this gross experience if I want to use the APIs that are already available because they're not just the right perfect shape.
In other words, the problem is really that when you have too many permutations from the client side, hey, you want 2 fields from the user and you want 5 fields from the user, and also their social security number or whatever, right? So
Exactly.
it's solving too many permutations problem. Because ideally, correct me if I'm wrong, I would still be more efficient if I would create a REST API that solves exactly your need, right? It's just that I cannot do that, right?
Correct.
I cannot
Exactly.
I cannot create an API exactly for you, right? And for Joe and Michael. But if I could, that would be better than GraphQL, right?
That would be better than GraphQL without Hasura. I'll come to the second piece of GraphQL with Hasura in a bit, but you're right. That's kind of one problem that GraphQL is solving, which is saying, let's get rid of this manual permutation and combination effort that will have to happen in some place or the other, right? Either on the integration side or on the production side. Now, the second key problem that GraphQL addresses systemically is that GraphQL is a little more like gRPC instead of REST, which means that when you build a gRPC API, it publishes the gRPC schema automatically. You don't do this extra work of documenting a schema and making that schema available. gRPC, for example, says, hey, you don't have to think about versioning if you're making non-breaking changes, right? If you're doing additive changes, versioning becomes really easy. So it's kind of got this idea that the schema and the type information of the API is built in to the API. With REST, you have to write a Swagger thing manually, right? You have to write an open API specification manually.
I'm out. I heard. I'm not doing that. Thank you so much.
Yeah, exactly.
I'm gone.
Right. And so this is why people like GraphQL, which is that any GraphQL API by definition has something called a GraphQL schema. You cannot have a GraphQL API without a GraphQL schema. Just like you can't have a gRPC API without actually the protos, right? Without having those definitions. So GraphQL is like that, and that makes the integration and documentation experience much richer, much more kind of easy to consume.
So you were talking there that GraphQL but Hasura. So what was the but Hasura here? Because you're pulling me in with that.
So Victor brought up this very nice point, which is that instead of me trying to build a generic GraphQL API thing, if I try to compare that to the performance and the ability to enforce security and all of that stuff on a single REST endpoint that I made, assuming that I had all the time in the world to make this custom REST endpoint, wouldn't my custom REST endpoint be better than this generic GraphQL business? And that's true if you're handwriting that GraphQL API, because you have to implement every single possible shape that can be fetched at runtime. So you still have to do the work, the heavy lifting of saying, oh, somebody wanted users and these 3 fields and user.accounts and account.transactions. So I'll have 3 different functions, and those 3 functions will implement as a breadth first kind of search. And I'll fetch all that data, I'll put it into like a JSON thing, and then I'll return that. So while GraphQL solves the kind of protocol problem, somebody still has to do the work of implementing each of those functions. Now, what we do is that we actually took this really, going back to databases, we took this really interesting stance on how to build the GraphQL API. What we said is, we're not actually going to implement functions, single functions that process a GraphQL query. What we'll do is we are a disguised kind of we're a compiler. We're a query compiler disguised as a web server. So when a GraphQL query comes in to Hasura, Hasura doesn't actually call a whole bunch of functions and do like a breadth first search and try to like fetch data from multiple places, which would be terrible. Compared to a REST endpoint, which could have done a really optimal data fetch, right? Maybe it made one join query because it knew that it comes from one database. One join query did whatever. What Hasura does is it behaves like a database. So it kind of creates this query plan, and it compiles, well, the right word I guess would be transpiles here, but it transpiles the GraphQL query into whatever language the underlying system speaks. So if a GraphQL query came in and Hasura kind of looked at the GraphQL query and said, all of this data comes in from Postgres. What I'm going to do with Postgres is I know that if I use a JSON aggregation query on Postgres and I get Postgres to create the right shape for me in JSON, that's the most theoretically efficient way of doing this. And I'll do a predicate push down. I'll enforce the authorization as well. I'll put the authorization as where clauses inside the SQL query. So I'll do like select ID, first name from user, where user dot account equal to current user dot family member. I'll do all of that. I'll compile this into the perfect database query, and then I'll hit it against the database. And if it's multiple databases, then I'll create a query plan that needs to hit multiple databases and then do a temporary table push down thing. This is kind of a technique that, like, say, virtualization systems use, where I'll take the subset of data from database 1, I'll create a temporary table in memory, kind of push down onto the second table, run a second query, and get that. So it gets to be as efficient as theoretically possible if you sat down and dedicated all your time and said, let me build the most perfect query plan to do this. And the reason why we're able to do that is because we took a compilation approach instead of like a bootstrap and generate some functions approach, right? When you're saying that Hasura auto-generates APIs, it doesn't actually kind of like auto-generate some functions that are now running. What it does is it's a compiler that can take dynamic queries and produce dynamic queries on the out. And that is kind of the secret sauce of where it's open source. So, open source secret sauce of how this works.
Legitimate open source. I was looking at that. It's Apache 2 and MIT was the mix that I saw. At least that's what it reported on the GitHub page.
Yep.
Thank you for doing really nice open licenses there. That's very good. And sort of shocking, critical, to be honest. But because there's also Hasura.io, which is the company, and you also have a Hasura Cloud offering. You can self-host. You can either pay Hasura to do your own thing, or you can just use the open source version of it. Don't know the differences. That's okay. But over on the cloud side, there's actually a free forever plan. And what does that really give somebody if they wanted to try it out? What will that free forever plan give you?
The free forever plan is meant for kind of like rapid development and iteration. The current free forever plan caps out at a certain amount of usage. I think it's maybe like 5 million operations every month. So it caps out at that, which is kind of a good...
It's 3 million. I'll keep you straight. According to the page, it says 3 million. So.
3 million, yeah. 3 million is a soft limit, I think, and I think we hard limit it at 5. So you have a 3 million operations soft limit where you can kind of keep making API calls, and that's really good for kind of local development. You have an MVP kind of situation, internal application that you're building out. And then once you kind of start crossing that scale, that's kind of when the paid tier kicks in. And of course, because it's our cloud-hosted version, you don't have to worry about, high availability and multi-region and all sorts of stuff.
Well, again, Hasura, that's Hasura, Hasura.io. Tanmai, thanks for being with us today.
Thanks for having me, folks. This was fun.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.